Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I hope that you all had a really good break and I missed you guys so much and I'm so excited to get back started with the semester with you. And I hope that you enjoyed your break. So let's jump in. So this is just a friendly reminder. I need your first and last name, the period, and the date in the top right-hand corner of your notes. If you could just take a minute and do that real quick, I would really appreciate that. I am going to have to start grading you and taking points away for not doing that because I had some kids turning in other people's notes last semester. And so this semester I'm gonna have to really enforce that you are in fact turning in your own notes. So please put your first and last name, period, and the date in that top right-hand corner. And I'm sure most of you are doing your own work and I really appreciate your hard work. So let's keep moving right along here. Let's do, so this is unit 4, lesson 1. Our main topic is polynomial functions. So we're going to be talking about all things polynomials today. You're going to learn how to name and describe polynomials just by looking at their equations. So our objective today is I will identify key features of polynomials, including end behavior, by reading the equation of the function. And you're going to show mastery by scoring at least 80% on today's extra practice. So let's talk about some key terms before we move on. So our first key term is a monomial. What is a monomial? Well, the word nomial, sorry, I don't know why I just paused. I just got distracted, I guess. Nomial means like terms. And then we know that like mon means one or mono means one. So monomial means one term. So a polynomial of one term. So a monomial could look like, let's do an example of a monomial, like 3x squared. Maybe monomial could be just the number 4, just a single term. So monomial is a single term. Polynomial, essentially, an expression that just has one term. Or maybe we have, let's say, 9xy cubed. All right, so those are just some examples of monomials. So then a polynomial, well, if you recall, poly means many, nomial means terms. Polynomial just means an expression of many terms. So an expression with one or more terms. So that means that a monomial, our single term, is still a polynomial. It's still part of the polynomial family. It falls under that umbrella because a polynomial just has to have one or more terms. But another example of a polynomial might be 2x plus 1. Or maybe 4x squared minus 7. Maybe negative 2 plus y. So these are expressions of polynomials, or I don't know why I just did all of those with 2 terms, but you could also have more than 2 terms. You could have like 3x squared plus 2x minus 1. That's also an example of a polynomial. Or you could have 4 terms or 5 terms or as many terms as your expression wants to have. All right, and then when we talk about standard form, we're talking about putting an expression in order by the degree of each term. So standard form is an expression written in descending order by the degree of each term. So what I'm talking about is when we do like 3x squared plus 2x plus 1. So when I talk about the degree of each term, I'm talking about the exponent. So the exponent of 3x squared is the 2. So x is being taken to the second power. So we put the x squared term first. Then for the 2x term, its degree of 2x would technically be 1. The exponent of this x is 1. So then 2, 1. And then technically, there is an x to the 0 power attached to the constant 1. So we have 1 times x to the 0 power. Because what is x to the 0 power really? Well, hopefully you recall that x to the 0 power is really just 1. So we have 3x squared plus 2x to the first plus 1 times 1, which would just be 1. So that simplifies back to what we had in the first place. I'm just showing you that. So our focus is up here. So we list the square, the 1, and then the 0 in order, in descending order like that. So for example, if we had an expression that looked like, let's see, negative 2x squared plus x to the 4th minus 7 plus x cubed. To put this into standard form, I would need to list the x to the 4th first. Then I would list the x cubed term, then the x squared term, and then the constant. So when I put an expression or a polynomial in standard form, I always want to list those higher degrees first, or those higher exponents, and then list them in descending order. So when I talk about degree, I know I just used that word a bunch without really telling you what it is, but the degree of a monomial is the sum of the exponents of each variable. So when I talk about the degree of, let's start with the 3x squared. So 3x squared was an example of a monomial. The degree of 3x squared is 2, because 2 is the only exponent of a variable. And so the sum of 2 is just 2. Now, what about the number 4? Well, remember, technically, there is a variable here. I'm going to do it in a different color. I'm going to do like x to the 0. There's technically an x to the 0 here. So the exponent of that variable is 0. So my degree would just be 0. Now, what about 9xy cubed? Well, now we have 2 variables. Hang on just a second. Sorry, I had to let my dog out real quick so we could go bark at the neighbors or the squirrel or whatever. So we're talking about 9xy to the 3rd. So remember that your degree is the sum of the exponents of each variable. So our variables are x and y cubed. Well, x technically has a 1 here and y to the 3rd. So my degree is 1 plus 3, or 4, because I have to add. I have to take the sum of the exponents of each variable. So when I talk about the degree of a polynomial, my degree of a polynomial is always the highest degree of any of its terms. So when I talk about the degree of an entire polynomial, I'm just going to take the highest degree of any single term in that polynomial. And we're going to do a bunch of examples of that real quick. So let me show you though. So the degree of 3x squared plus 2x to the 1st plus 1, the degree of this would be 2. It's degree 2 because that is the highest degree of any of these 1 terms. If we had x to the 4th here, plus x cubed for this expression, the degree would be 4 because that's the highest degree of any term in that polynomial. So let's talk about a whole bunch of different examples and a whole bunch of different things and how we would name them. So for example, if a polynomial has degree 0, we call that a constant. So for example, our constant would be like the number 5. Well, this expression also only has 1 term, so I call that a monomial. This is a constant monomial. The number 5 as an expression is a constant monomial. All right. So then what if we have degree 1, like x plus 2? The highest degree of any of these terms is a 1, x to the first. So I have degree 1. The name of this is linear. This polynomial is linear. X plus 2, if we graphed it, would create a straight line. Well, we have 2 terms, and we call that a binomial. See these word roots? All right, 4x squared. Well, 4x squared only has 1 term, so it's still a monomial, but it has degree 2. So because it has degree 2, we call it a quadratic. Why can't I spell the word quadratic right now? Quadratic. All right, what about our next example? We have 4x cubed minus 2x squared plus x. Again, we have 3 terms here, so we call that a trinomial. The highest degree is 3, so I have degree 3, and I call that a cubic. This is a cubic trinomial. A cubic trinomial. Then I see I have 2x to the 4th plus 5x squared. My highest degree is a 4. We call that a quartic. That's why I said that weird. I was thinking about the word I was about to say. We call that a quartic. So 2x to the 4th plus 5x squared. So that has 2 terms. So I'm going to call that a binomial again. So we've got a quartic binomial. Then for our last one, our expression is negative x to the 5th plus 4x squared plus 2x plus 1. Our highest degree is degree 5. So at this point, we can use the word quintic to describe this, or you can just tell me that this is a degree 5. After 4, we just kind of start saying, after degree 4, we just start saying like this is a degree 5 polynomial. Degree 5 polynomial with 4 terms, so I would call that, we just say a polynomial of 4 terms. So up to 3 terms, you say monomial, binomial, trinomial, and then after that, you just say a polynomial of however many terms. So I would say this is a polynomial of 5. Just kidding, that's 4 terms. I'm silly. So you would tell me that this is a degree 5 polynomial of 4 terms. All right, so now we're going to name each polynomial or classify it based on its degree and the number of terms. Before we do that, though, we always want to put it in standard form. So for example 1, part A, we've got 3x minus 9x squared plus 5. To put it in standard form, I want to order each term by the highest degree and descending order all the way to the lowest degree. So I'm going to put negative 9x squared first, followed by 3x, followed by that constant 5. So now I need to name this thing. Well, I see that my highest degree is a 2. And I learned today that degree 2 is called a quadratic. And then I've got 1, 2, 3 terms. And to name something with 3 terms, I call it a trinomial. So this is a quadratic trinomial. Is how I would classify it or name it. So part B, I want you to do 4x minus 6x squared plus x to the 4th plus 10x cubed minus 12. You're going to go ahead and classify that by degree and number of terms after you put it into standard form. Press pause and then press play when you're ready to check your work. So after putting this into standard form, your polynomial should read x to the 4th plus 10x cubed minus 6x squared plus 4x minus 12. Then you should notice that we have a degree 4. Our highest degree of any of these terms is 4, so it's degree 4 or quartic. And then we have 5 terms. So we name it by saying we have a quartic polynomial of 5 terms. All right, so let's learn a couple more things. Well, we've actually already discussed end behavior, but that was a while back in semester 1. So we're going to review end behavior just to make sure we remember what end behavior is. So if you recall, end behavior describes the behavior of a graph from the far left to the far right. So it describes the behavior of a graph as it extends to the far left and the far right. And then we're going to add a new term to our vocabulary today, turning points. So when I'm talking about the turning points of a graph, I'm talking about points where the graph switches direction. So a point on a graph where it changes from, when I talk about like direction, I'm talking about increasing or decreasing. You know, fancy way of saying is our graph going up or down. But, you know, we're going to talk like mathematicians. So we're talking about the graph where it changes, a point where it changes from increasing to decreasing, or vice versa. Maybe it was decreasing and now it's changing to increasing. So for this next example, we're just going to read the graphs of these polynomial functions, and we're going to describe the end behavior and the number of turning points that each function has. So I know before when we described end behavior, we talked about it in terms of as x approaches infinity, y approaches infinity, or whatever. Well, for the sake of this lesson, we're just going to describe end behavior as literally like whether or not a graph ends, its end behavior goes up and down and up, etc. However we describe it, we always describe what happens to the far left first and then the far right. So for this function, what happens as our graph extends to the far left? Well, our graph is increasing, so we're going to say that our end behavior to the left is up. Then our end behavior to the right, well, our graph still extends up, it still increases, so we say up and up. So our end behavior is up and up. Well, then we need to talk about the number of turning points. So remember, a turning point occurs when your function goes from like increasing to decreasing, or it switches from decreasing to increasing. So for example, as this curve approaches this point, we're decreasing. But then after this point, we're suddenly increasing. That makes this point a turning point. Then up here, well, we increase until we get to that point, and then suddenly we decrease. So that makes this another turning point. Then I see another turning point here because our graph decreases, and then at this point, it increases again. So I found a third turning point. So we've got 1, 2, 3 turning points here. All right, so it's your turn. You're going to describe the end behavior. Remember to describe the far left first and then the far right. And then you're going to tell me the number of turning points that this function has. Press pause and then press play when you're ready to check your work. Good luck. All right, so for this function, to the far left, we're decreasing or going down. So I would say down. And then to the far right, our graph is increasing or going up. So this is just a symbol for up. So that should say down and up for our end behavior. Then for turning points, I counted 1, 2, 3, 4 turning points in total. Okay, so something kind of cool happens when you read a polynomial function. There's kind of a cool pattern that occurs. And we don't even need to see the graph of a polynomial function to know its end behavior. We can actually know the end behavior of the function just by reading the function itself, just by looking at the equation. And what we always look at is the leading term, that very first term of the function. And I'm going to show you some examples of that in example 3 here. Just by looking at 4x cubed, we're going to know whether or not this graph goes up and up for its end behavior, down and down, up and down, down and up. We're going to be able to tell just by reading 4x cubed. So let me tell you how. Well, to determine the end behavior of a function, you want to make sure that it's in standard form. And this is just a fancy way of writing a function in standard form without using specific numbers. So like a sub n x to the nth plus a sub n minus 1, x to the n minus 1. It's just a fancy way of writing like 4x cubed plus 2x squared minus 3x plus 1, all the way until you get to your constant. All right, so these are just ways to represent each of those terms in descending order by degree. So the thing you want to look at is you always want to look at the first term, a sub n x to the n. And that, again, is just a fancy way of writing. For example, we already have 4x cubed. So a sub n just represents your coefficient, and then x to the n is your variable and its degree. So n is just the degree. So here's the thing. If a is positive and your degree is even, so if your leading term is positive and the degree is even, your end behavior will always be up and up. But if a is positive and your degree is odd, your end behavior will always be down and up. Then if your leading term is negative, so if a is negative and your leading degree is even, so if a is negative and your degree is even, you will always have down and down as your end behavior. But if a is negative and the degree is odd, your end behavior will always be up and down. So we can actually use this little chart, and you might want to like highlight this chart and make sure it's just visible and handy in your notes, so you can use it to help you describe the end behavior of a polynomial, like on a quiz or a test or your homework perhaps. So if we look at g of x equals 4x cubed minus 3x, we're going to look at that first term, 4x cubed. Well, 4, our leading coefficient, is positive. This is a positive number. And then the degree, 3, is odd. So we're positive and odd. So we're going to look back up at our chart. We're looking for positive and we're looking for odd. Well, if it's positive and the degree is odd, our end behavior will be down and up. So my end behavior is down and up. All right. So now it's your turn. So look at h of x equals 8x squared plus 8x cubed minus 2x to the 4th plus 2. Look at that leading term, negative 8x squared. By just looking at that term, I want you to tell me what the end behavior will be. So what is your end behavior? Up and up, down and down, down and up and down? I don't know. You tell me. Press pause and then press play when you're ready to check your work. So because the coefficient is negative and the degree is even, our end behavior should be down and down. Hopefully that matches what you got as well. All right, so there's just one more thing I want to point out real quick, and then I will set you off to go work on your extra practice. But what I want to talk about is this graph. So by looking at the graph, I know that this function has an end behavior of up and up. Well, functions that have an end behavior of up and up I don't know what the function is. F of x equals whatever the equation is. I wasn't given the equation. I was just given the graph. But because the function, the graph of the function has the end behavior of up and up, that tells me that the leading term was positive and the degree was even. So I know that because our end behavior was up and up, our leading term, a sub n x to the nth, that a is positive and n is even. The degree is even. So that means that my degree has to be an even number. So my degree could be 2. It could be 4, it could be 6, etc. But what would the least degree of this function actually be? So I know that for a degree 2 polynomial, I would have a quadratic, which means I should have a parabola. So if this graph was a degree 2, it would be a U-shaped graph. And this function is not a U-shaped graph. It's more like a W. So I know because of that, that it's not a degree 2. So that means that the least degree that this function could be is actually degree 4, because it has to be even and it has to be at least 4. It could be 6, it could be 8. So that just means that my function, f of x equals whatever, is going to be at least some number a times x to the 4th or 6th or 8th. It has to be an even number. All right, so that's it for today. Go ahead and start working on your extra practice. Of course, if you need help, just hit that ask for help button. And when you're done, you're going to submit it as a PDF to Schoology and then hit that ask for help button and we'll go over it together. So again, welcome back. I'm excited to start this new semester with you and I will see you all back in class. Have a good day.